At 4:09 a.m. Coordinated Universal Time on July 19, 2024, the world's digital infrastructure simply stopped. In a matter of minutes, commercial flights were grounded, 911 dispatch centers went dark, and hospital networks froze. Across the globe, 8.5 million computers simultaneously displayed the exact same error, the infamous blue screen of death. When critical systems across entirely different sectors fail at the exact same moment, the immediate assumption is that you are watching a highly coordinated nation-state cyber attack unfold. But there was no malicious hacker. The culprit was a routine, automated security update pushed out by the cybersecurity giant CrowdStrike. The event caused tens of billions of dollars in financial damage globally. It was the result of the very security software organizations pay to keep their systems running. CrowdStrike makes a flagship security product called Falcon. It's an endpoint detection system designed to scan computers for threats. To understand how it caused so much damage, we have to look at exactly where it operates inside your machine. This architectural model shows how Windows is divided into strict layers. At the top is user space, where applications like web browsers run. Down at the very bottom, forming the foundational core, is kernel space, known as Ring 0. Falcon is an early-launch anti-malware driver. It operates in Ring 0 to turn on before the rest of the computer boots up. This allows it to intercept deeply embedded viruses, called rootkits, before they hide in the operating system. Operating at this foundational level grants a security program ultimate defensive power, but it comes with an extreme trade-off. A single coding error in Ring 0 bypasses all safety nets and instantly kills the entire machine. On July 19th, CrowdStrike sent out a routine configuration update to its Falcon sensors, delivered via a small piece of code known as Channel File 291. This schematic illustrates the exact coding error. The new update carried a template that required 21 input parameters to function properly. However, the system's internal content interpreter was only programmed to accept 20. In a fraction of a microsecond, the system tried to read that 21st value. It hit empty memory space. This triggered an unrecoverable out-of-bounds memory read, forcing Windows to shut down entirely to protect itself. No sophisticated hacker triggered a collapse. A microscopic quality assurance oversight, a mismatch in basic data inputs, simply bypassed standard validation testing and shipped to millions of machines. Once CrowdStrike realized the mistake, they rolled back the update. So why couldn't they just push a software patch over the internet to fix the computers that had already crashed? Looking at a boot timeline, the problem is clear: a dead agent race condition. Since the error was embedded in Ring 0 during early boot, computers crashed before network stacks could initialize. They had no internet connection to receive the fix. This forced IT administrators to physically walk to millions of individual servers and laptops, boot them into safe mode, and manually delete the bad file. The process was agonizingly slow, largely because technicians had to manually type in unique 48-digit BitLocker encryption keys for nearly every device. The most advanced, cloud-delivered cybersecurity infrastructure on the planet was brought down by a bug that could only be resolved by human hands typing at physical keyboards. Outside the code, the physical logistics of the world ground to a halt. Essential operational software, like the centralized crew tracking systems airlines rely on, were trapped in the continuous crash loop. Delta Airlines was hit exceptionally hard. Over the course of a multi-day operational meltdown, they were forced to cancel 7,000 flights. Delta estimates the outage cost them $500 million. They've since launched a high-stakes legal battle targeting CrowdStrike's leadership to recoup the damages. The failure demonstrated that code doesn't exist in a vacuum. A single out-of-bounds memory read in a small configuration file was enough to directly halt global aviation. More broadly, the outage exposed the terrifying fragility of our tech monoculture. When over half of the Fortune 500 relies on the exact same kernel-level security architecture, it creates a single global point of failure. In response, Microsoft introduced the Windows Resiliency Initiative. They are now working to redesign how Windows handles security, aiming to push third-party antivirus software out of the kernel entirely. In the effort to protect systems from external attacks, organizations granted deep kernel access to a single provider. It only took one missing line of data to show how that same level of access could unintentionally take the world offline.